KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Okay students, now in this video we are discussing continuation information of post fertilization events. Students, now in this video we are discussing continuation information. Continuation information of post fertilization events. So in post fertilization events also, where we are concentrating more means we are concentrating here. So where on the embryo. Okay, so in embryo, so in previous video I have given 2 or 3 points, those points also now here I have included. Why? Because here if I include previous 2 points means, so that will be from the starting. So means from the starting of embryo development to till completion of embryo development, and new information also I have brought up. So what are the differences between Dicot embryo and Monocot embryo? So particularly if you say strictly this entire information you people don't know before. So Neet examination point of view, this one I have brought for newly. So now let us see. Embryo. Zygote elongates. First of all, why? Because the embryo development point of view, first of all, development of embryo there starts with a zygote only, no. So there zygote elongates and divide into upper and lower cells. So means when this particular zygote elongates, so that particular zygote divides into upper and lower cell. Upper and lower cell. Now lower one lying towards the micropylar region. So what is our lower cell is there now? That particular lower cell is lying towards the micropylar region. Further divides in one direction into a row of cells called as a suspensor. So my dear students, so while using the term of suspensors, you try to remember previous video. So there diagrammatically I have given explanation. Okay. So lower, what is a cell is present towards the lower side, means exactly towards the micropylar region. So that one forms a suspensor. Next one, upper cell, which is situated towards the antipodal region. So what is a cell which is situated towards the antipodal region? We will be taking as embryo cell. Means here we are studying like that, means now the once you see one more time, once you see lower one or lower cell lying towards the micropylar region. If micropylar region is there in lower side, means the ovule structure micropylar region is down and the chalazal region is up. Means inverted ovule structure we are observing. Okay, so inverted ovule. So generally we will be taking off orthotropous ovule type, but here anatropous ovule information they have given. Okay, in anatropous ovule only. So if you see the structure of micropylar region, that will be down and the chalazal region will be up. Okay, so now here what is a cell which is present towards the micropylar region, that forms the suspensor, and what is a cell which are present towards the antipodal regions, forms the embryo cell. Okay, now first cell of the suspensor often enlarges and produce haustorium or absorbing organs. Means here the first cell of suspensors. So suspensors definitely produces or can produce which one? Haustorial cells or haustorial organs. So what is the use of these haustorial cells or absorbing organs? Means once we learn, definitely absorbs the food materials. Next one, while terminal cell. So while terminal cell forms the which one? Apophysis or hypophysis. hypophysis. This particular cell gives rise to the apex of the radicle. Okay, apex of the radicle. Next one, upper cell or embryo cell enlarges and divides repeatedly to form 8-celled so from here onwards we have to learn. So upper cell or embryo cell. So what is the upper cell which is lies towards the or which is situated towards the antipodal cells now. So that particular cell or the particular embryo cell enlarges and divides repeatedly to form 8 cells. Okay, these 8 cells that are arranged in 2 tiers. So that are arranged in 2 tiers. So one tier name is epibasal and one more tier name is hypobasal. So you can remember like a tier only. So one tier name is epibasal, means epibasal tier also known as terminal, and hypobasal near suspensor. So hypobasal one which is situated towards the suspensor or near suspensor. Next one epibasal one, terminal one. Okay, now here what is the information? Former means epibasal. Former form 2 cotyledons and the plumule in cotyle. In dicots means once you see epibasal is a former now. The former forms 2 cotyledons and the plumule one more means 2 cotyledons, and the plumule of dicots means in dicots plumule formation as well as cotyledons formation is under the control of epibasal, or epibasal forms the two systems. One is 2 cotyledons and one more is plumule. Next one cotyledon and one more. In monocotyledons, one cotyledon is there now. That is only we are calling as a scutellum. That scutellum also is formed from the epibasal in case of monocots. Once you see there, embryo cell is there, this particular embryo cell divides, so furtherly divides and 8 cells of formation takes place. No, these 8 cells are divided into 2 parts. 2 tiers means 2 parts. One is epibasal and one more is hypobasal. Epibasal, what it is doing? Definitely it forms, in case of dicots, it forms 2 cotyledons and plumule, and in case of monocotyledons, that forms the scutellum. Scutellum only we will be calling one cotyledon name. Okay, now here later one means here hypobasal one. What is the use of this hypobasal one? Means form hypocotyle region. So this particular one means a hypophysis forms a hypocotyle region. Easy the hypobasal forms hypocotyle region. So except its tip means except a tip or except its tip, definitely it forms the hypocotyle region. Why? Because in a hypocotyle region, if you see there, the root cap also or root tip will be there, except that particular tip, definitely hypobasal one involves in the formation of hypocotyle region. Okay, this one time remember pannikonga. First of all, one zygote cell is there, that one, once you listen carefully, one zygote cell is there, that one divides into 2 cells. So there, once you see there, the lower cell which is situated towards the micropyle region divides suspensor cells, and what is the upper cell is there, which is situated towards the antipodal one, that one embryo cell madari convert. This is embryo cell, so furtherly divide means here first cell of the suspensor. In a suspensor point of view, this particular first cell of a suspensor converted into haustorium. Next one embryo cell point of view, embryo cell or terminal cell. Embryo cell we will be calling by one more name, terminal cell. We will be it is involved in the formation of hypophysis and gives rise to the radicle. Now here the upper cell or the embryo cell, okay, upper cell or embryo cell, that one divides repeatedly and form 8 cells. So these 8 cells are divided into 2 tiers. One is epibasal one and one more is hypobasal one. Epibasal one involves in the development of a plumule and 2 cotyledons in case of dicots, and in monocotyledons, epibasal one forms 1 cotyledon. Next one hypobasal one forms hypocotyle region except its tip. Okay, next one the subsequent divisions. The subsequent divisions means here, so first of all 2 cells are there, 1 cell, lower cell, upper cell. Lower cell results in the form, lower cell forms the suspensor and upper cell forms the embryo cell. Now here the first cell First cell of a suspensor forms the ostoria. Next one, a terminal cell forms the hypophysis, and that particular hypophysis gives rise to the radicle. Next one, upper cell. Upper cell, what is upper cell is there now, or embryo cell. That particular cell divides and form 8 cells. 8 cells. So these 8 cells are divided into again 2 tiers. So 8 cells are divided into 2 parts. So there one is epibasal part and one more is hypobasal part. Epibasal part no plumule formation and cotyledon formation, and monocotyledon's point of view one cotyledon formation also we can see. Next one, hypobasal involves in the formation of hypocotyl region. Okay, next one, subsequent divisions. So here while this particular embryo divides subsequently, automatically first of all globular embryo formation takes place, later heart shaped embryo formation takes place, later completely matured embryo formation we can see. Next one, typically Dicot embryo consists of an embryonal axis. If you see particular Dicot embryo, already we have seen this one. If you take a Dicot embryo consists of an embryonal axis. Embryonal axis is there, embryonal axis, and 2 cotyledons are present. If you see one particular embryo, Dicot embryo, there one particular embryonal axis is present, and along with the embryonal axis we can find out 2 cotyledons. Okay, 2 cotyledons. Next one, the portion of embryonal axis. The portion of embryonal axis above the cotyledon. Once you will see the portion of embryonal axis above the cotyledon, we will be taking as epicotyl region, while below it is we will be calling as hypocotyl region. Once you see, already with this particular point we have learned in our classes, but I would like to explain by one more time. So the portion of embryonal axis above the cotyledon. So what is the embryonal axis is there, which is situated above the cotyledon, epicotyl region, while below we will be taking as a hypocotyl region. Now epicotyl terminates in plumule, and while hypocotyl terminates in radicle. Okay, now plumule gives rise to shoot system, while radicle gives rise to root tip. Okay, radical definitely root system and root tip. Next one, if you see a mature embryo in monocotyledons has a single cotyledon known as scutellum. Already so many times we have discussed this one. Okay, if you take what is a mature embryo is present there, mature embryo in monocotyledons has, what is a mature embryo? Definitely, suppose if you take one mature embryo of monocotyledons, definitely has a single cotyledon. So that particular single cotyledon name is scutellum. Next one, at a lower portion of scutellum. Where at a lower portion of scutellum, the portion of embryonal axis we will be taking as radicle. So which bears like apical meristems. So definitely their apical meristems are there, and root cap also is present at lower end. The root cap also is present at lower end. Okay, now so this is a well known information already in our regular classes we have seen. Now let us start to discuss the differences. Let us start to discuss the differences between the Dicot embryo and Monocot embryo. Dicot embryo and Monocot embryo. Now here once you see their tabular point of view, serial numbers, characters, and Dicot embryo and Monocot embryo. Now let us distinguish. So what are the main important points or the differences are there? So in between the Dicot embryo and Monocot embryo. Now characters once let us have a look. So characters point of view, number of coleoptiles, position of plumule, position of cotyledon, coleoptile, coleorhiza, scutellum, and suspensor. One more time, what are the characters? Number of coleoptiles, position of plumule, position of cotyledon, next one coleoptile, coleorhiza, scutellum, suspensor. Okay, now number of cotyledon point of view in a dicots, one by one let us see. Okay, in a dicots, dicot embryo, later let us see monocot embryo. Now here once you see here number of cotyledons. So here now I have changed this one. number of cotyledons there. In a dicot embryo, how many number of cotyledons we can see? 2 cotyledons. In a dicot embryo, 2 cotyledons are present and are attached to the embryonal axis. One more time you see there. In a dicot embryo, total number of cotyledons, how many are there? 2. Enough. Okay. Next one, position of a plumule. So position of a plumule point of view occurs distantly or distally. Okay, so occurs distally. Next one, the position of cotyledon is occurs laterally. Okay, once you see the position of a plumule occurs distally and the position of cotyledon occurs laterally. Next one, coleoptile. Coleoptile is present or absent? So in a dicot embryo, coleoptile is absent. Next one, coleorhiza. Coleorhiza also is absent. Next one, scutellum. Scutellum also is absent. Next one, in a suspensor. Suspensor is large suspensor is present in a dicot embryo. One more time you see number of cotyledons, position of plumule, position of cotyledon, coleoptile, coleorhiza, scutellum, and one more is suspensor. Now suspensor in a dicot embryo, very large one. Scutellum is absent, coleorhiza is absent. Next one, coleoptile is absent. Position of cotyledon occurs laterally and position of plumule occurs distantly or distally. Next one, number of cotyledons or how many are there? 2 cotyledons are there. So this is a small information regarding dicot embryo characteristics. Now let us see the information of monocot embryo. Monocot embryo point of view. Now here, how many number of cotyledons are there? Number of cotyledons in a monocot embryo, only 1 cotyledon, that is also attached to the embryonal axis. Next one, position of plumule occurs laterally. Position of plumule occurs laterally. Next one, position of cotyledon, a single coleoptile occupies terminal position. Okay, one more time you see there. So here the position of cotyledon point of view. So here second one. So second one, position of plumule point of view, it occurs laterally, and the position of cotyledon point of view, in case of monocot embryo, a single coleoptile occupies terminal position. Or here, instead of a single coleoptile, here we can be considered, or what we here we can be taken, no, we can take a cotyledon. So thereby a single cotyledon occupies terminal position. Why? Because here cotyledon only is present. Okay. Next one, coleoptile point of view. Now you see there, position of cotyledon in a monocot embryo. How many cotyledons are there? A single cotyledon occupies terminal position. So in a terminal position we can find out the presence of single cotyledon. Next one, coleoptile point of view. It is the envelope of which one? Coleoptile, it is the envelope of plumule and definitely protects the plumule. Okay. Next one, coleorhiza. It is also protective envelope or protective sheath only which protects the radicle. Which protects the radicle. One more time you see there, coleoptile protects the, one time I said coleoptile, coleo common. So here tile and rhiza is there, no. So P protects the plumule and R protects the radical. Likewise I have given information, isn't it? Next one, scutellum information point of view. In a monocot embryo, once you see there, monocot embryo, a single cotyledon is present. So that, but in monocot embryo, single cotyledon only we will be considering as scutellum. Next one, suspensor. In case of monocot embryo, comparatively small. Means here in a dicot embryo we have seen very huge or the very large which one? Suspensor is present. But in a monocot embryo, so when compared to the dicot embryos, suspensor, no, that will be small. So this is just tabular information. So by searching of some other book, no, they have given, but there few mistakes are there, but I corrected now while taking class. So I have corrected. You can follow my table clearly without any doubt. So differences between dicot embryo and monocot embryo point of view. So number of cotyledons, position of a plumule, position of cotyledon, coleoptile, coleorhiza, scutellum, suspensor. So likewise somewhat differentiation points we brought together and we have discussed now. Next one, seed. So last and final concept in sexual reproduction in flowering plants. But today this particular topic, in this video, this particular topic will not be completed. So I will complete this one. Somewhat information I have to give related to the apomixis and polyembryony. So after completion of that information, I will conclude this. I will complete this. Now let us learn the information under seed. Now seed, it is a fertilized ovule. Seed is a fertilized ovule. So it is the final product of fertilization. Listen carefully. So seed is there. This particular seed is a fertilized ovule. That particular seed is final product of. It is a final product of fertilization in case of angiosperms. Next one, it acts as a main propagative unit in plants. So why? Because here we are observing the plants or the germination of the plants or the propagation of the plants, means just we are observing that kind of a phenomenon when these seeds has the capability to germinate. So that's why only we are obtaining seeds or the small plantlets from these seeds. Means, so thereby here what is the point? Seeds definitely involves in the propagation or propagation units. So definitely these seeds we can consider as propagative units in plants. Now after fertilization, so what are the parts are changed or the transformed into another parts? Let us see now. Once you see the side heading, the transformation of various units of ovary during seed formation. So one more time, transformation of various units of ovary during seed formation. So first one is ovary wall. Ovary wall after fertilization converted into fruit wall. Ovary after fertilization converted into fruit, and integuments after fertilization converted into seed cones, and outer integument converted into texture, inner integument converted into tegmen, and ovule converted into seed. So means maximum all these points you know very well. Now here ovary wall converted into fruit wall. Now this particular fruit wall we will be taking or we will be giving by one more name, that is pericarp. Next one, here few things I didn't write, but once you see nucellus, suppose here the nucellus is there, after fertilization converted into pericarp. So both conditions are deployed. So already in first chapter that particular information I have given. So next one, likewise there are different types of units after fertilization transformed into another names. Okay. So now here during seed formation, while development of seed formation, embryos. So embryos development, how it will be now? While developing of embryo, suppose if the endosperm is completely developed or the completely not completely consumed or not completely consumed, means so based on that one, seeds now we have been divided into two types. One is endospermic seeds and one more is non-endospermic seeds, isn't it? So now here endospermic seeds and non-endospermic seeds, now we can take one more name. Endospermic seeds we are calling by one more name albuminous seeds. Next one, non-endospermic seeds we are calling by one more name non-albuminous seeds. Listen carefully. Endospermic seeds, albuminous seeds. Non-endospermic seeds, non-albuminous. So that is a small information regarding types of endosperm. Later one more information. So after completion of which one fertilization and everything, so we have seen, so fruits are two different types of fruits are there. One is false fruits and true fruits, likewise we have seen. So false fruits means, so here the complete development of a fruit portion takes place other than the ovary, but including the ovary, other than the ovary means suppose for example if you take an apple, so apple edible part is developed from the thalamus. So next one, your true fruit also will be there, but that particular true fruit will be there within the fruit, or the which one, false fruit. So thereby false fruit means, suppose if the fruit development is there along with the ovary. So means here along with the ovary means here the edible part which is developed from the other than the ovary, but in that particular case there is the involvement of ovary. There is involvement of ovary. Okay, simply one point you try to remember. What is the point? No, false fruit means what is the edible part is there? No, that is not developed from the ovary. That is developed from the other part of the ovary. Okay, for example, thalamus in case of apple, and for example pedicel in case of anacardium occidentalis. So this is a small information regarding which one post fertilization events. Here so many important points I have given. Once let me revise, later I will conclude. Once you see there, from down I will move up. Ovule after fertilization converted into seed, inner integument converted into tegmen, outer integument texture, integuments seed coats, ovary, fruit, ovary wall, fruit wall or pericarp. This is information. Next one, the differences between differences between a Dicoty embryo and a Monocot embryo I have given. Okay, this information also once you go through. So later post fertilization events, so there first of all endosperm development will be there. Once the completion of endosperm development, so we can see the development of embryo. Why? Because endosperm is acting as a nourishment tissue for the thereby it supplies of food materials to the developing embryo. So here the embryo mostly endosperm haploid will be triploid in condition, but somewhat exceptions also in previous class I have given. But embryo definitely always will be diploid in condition. Why? Because embryo which is developed from the diploid zygote. So this is a small information regarding post fertilization events. In the next video, uses of seeds I will give you later after completion of uses of seeds, apomixis and polyembryonic information. Somewhat new information is there, that one I will discuss with you. Thank you and be safe at home.